Good afternoon, and welcome to the Society of Wetland Scientists August 2020 webinar titled Restoring Native Clam Communities for Improved Water Quality and Economic Resilience in the Indian River Lagoon, and presented by Dr. Todd Osborne. My name is Katie Cruz. I'm going to moderate this webinar and engage you in an e-learning experience with SWS during a time when many of you may be sequestered at home like me. This is our way of staying connected to the wetland community during the global pandemic, and we hope you all are well. For those of you who may not be as familiar with our SWS webinar series, all of our monthly webinars are complimentary to SWS members and are usually held on the third Thursday of the month. For each quarter, we open up our webinars and offer them free to non-members and the public. As you can see on this listing for our upcoming webinars, we have both our regular SWS webinar series in English and also have quarterly webinars offered in Spanish. Our next free quarterly webinar will be held in September 2020, titled Urban Wetlands and Water Management, and will be presented by Bill Dooley. We are proud to announce that we have 4 organizations that are sponsoring our SWS webinar series. The first is Water Resources, Hydrology, and Hydraulics Education Group, which is a nonprofit group that shares information on water resources, hydrologic, and hydraulic engineering to help educate and build a better tomorrow. Please visit, like, and follow this sponsor. And the Winton Group, which is a natural resource consulting firm that balances regulatory compliance with sound ecological management. You can find their information at the websites listed above. The next 2 SWS webinar series sponsors are In Situ Monitoring Equipment and Software works together to make it easier and more cost-effective to collect, access, and manage water levels, water quality, water flow, and more. And the Wild Note is a field data collection app for environmental professionals that streamlines the process of collecting, managing, reporting environmental data so you can work smarter, not harder. You can also find their information at the websites listed above. Please make sure to visit their websites or like and follow our SWS webinar sponsors' social media pages. Next slide. Since January 2018, we've had most of our SWS webinars approved by the SWS Professional Certification Program as being applicable for continuing education credits. These credits can be applied to professional wetland scientist certification or renewal or other certifications. And we are proud to announce that this webinar has been pre-approved by the SWS Professional Certification Program as applicable for continuing education credits. Participation certificates are available through an automated process. You will receive an email from our SWS Managing Director, Michelle Kosek, about 1 day after the webinar. Please check your spam email if you don't see it. These certificates are free to SWS members and are available for non-members for a nominal cost of $20. Participation certificates are also available for those who watch webinar recordings, which can be found on our past webinars page or on our YouTube channel, complete with multilingual captions. Before we get started, I'd like to go over a few housekeeping items. The general format for today's webinar will be a 45-minute presentation by our speaker, followed by approximately 15 minutes for questions. All attendees will be muted. Attendee questions should be typed in the Q&A button shown here, and you can do that at any time during the presentation. Additionally, participants may upvote questions in the Q&A that they would like to see answered first. As the moderator, I will pose the questions to our speaker at the end of his presentation. The chat pane should not be used for questions. Rather, if you have any technical difficulties or general comments, you may post them in the chat. Jordan from the SWS staff will regularly check the chat box. The PDF of these slides are hosted on the SWS website. And don't forget to tweet about today's webinar at #SWSwebinar. So with the logistics out of the way, let's get started with our webinar. It is my distinct pleasure to introduce our speaker today, Todd Osborne. Dr. Todd Osborne is an associate professor of estuarine biogeochemistry at the University of Florida's Whitney Laboratory for Marine Biosciences in St. Augustine, Florida. Todd has a faculty appointment in the Soil and Water Sciences Department and maintains affiliate faculty status in the School of Natural Resources and the Environment, UF Water Institute, and Florida Sea Grant. Dr. Osborne's research interests revolve around biogeochemical cycling of ecologically relevant elements in wetlands. And if I may also note, is my graduate advisor at UF, making it even more of an honor to introduce him. So with that, I will hand over control to Todd. Welcome, Todd.
Hi, and thank you. Thank you very much for the opportunity to speak today to the SWS audience. I just want to say I've been a member for a long time. Ronnie Best captured me as a graduate student and told me I must join. That was back in 1998. And I think it's a fantastic group, and we've done a lot in the last 20 plus years that I've been around. But anyway, thank you so much for the opportunity to speak. I do want to talk to you about clams today and about using a different, maybe unique approach to improving water quality in wetlands. I know a lot of us are practitioners in wetland restoration and ecosystem restoration, so I'm hoping this would be useful. Now, before I get started, I want to say a big thank you to my co-authors, Jose Nunez, who is my right hand in this project. I call him the Clam Whisperer. He is the one who is able to spawn and work with these animals and made this possible. Jeff Beal from FWC is a critical link in all that we do in the Indian River Lagoon. Anna Thornton, my lab manager, Lorraine Simpson from FOS, Sabrina and Norman from my team in the field. Let's see, I've got the control going. Okay. I also want to acknowledge that this is a really big effort. This project was grassroots when we started, and we have a lot of collaborators. And I want to acknowledge them as well because they all have a very important role in the work that we're doing. And I'll start with the Water Management District, St. Johns River Water Management District, and their scientist team there works in the Indian River Lagoon and have for many, many years and have been able to provide expert guidance in the way this works. FWC, of course, and the Indian River Lagoon National Estuary Program, and the funding comes through them to the IRL Council that supports a lot of our work. I'd like to say thank you to the Brevard County or Space Coast Office of Tourism, and we give it all to Brevard, and other groups, Coastal Conservation Association, Fish America, Starbright, who's a big sponsor of my good friend Blair Wiggins and his television show Addictive Fishing. And I'm just going to say up front that without linkages to the public, these kinds of projects would not work. And so I say that Blair and his team at Addictive Fishing Television have been most instrumental in helping us move this idea forward, both to the public and to the local governments that are allowing us to do it. Also, a big thank you to Premium Seafood, who's here locally in St. Augustine, where I am, and helps me with all of the clam production. Okay. So a quick outline of what I'm going to talk about today. I want to introduce the Indian River Lagoon ecosystem for those of you that aren't familiar, and describe some of the problems that have led to its current condition. You may have seen in the news last year that it was on the verge of ecological collapse. And I think that is a true statement. I want to discuss the role of clams in combating this problem. It's a recurring issue of harmful algal blooms and nutrient enrichment, which is all too common today, I guess, with all of us working in aquatic systems. I want to give you a kind of view of the current state of our restoration initiative and what our current findings are. And we're in process, so this is not a post-action report. And so I want to elaborate also on the next phases. But the goal that I have for this presentation really is to provide you, both scientists and practitioners, with some compelling evidence to support the broader use of shellfish in wetland restoration efforts. And I think that you'll see where we're going with this, that it's a maybe unique right now, but I think it's going to catch some interest and be utilized more broadly. Okay, so a quick overview of the IRL. The map on the right shows you this is Central Florida. extending from Volusia County to the north all the way to Palm Beach County to the south. There is about 156 miles of estuary here, and a lagoon protected by a barrier island. And it ranges from 0.5 to 5 miles wide. And then it's made up of 3 main water bodies: Mosquito Lagoon to the north, the Banana River right near Port Canaveral, and then the Indian River Lagoon, which we call this whole complex often, is the rest of that system. And it's a pretty big watershed, 22,000 or 2,200 square miles, sorry. And it's an estuary of national significance. The big catch here to me is that the economic value to these counties, estimated in 2007, so this 13-year-old number here, but it's $3.7 billion in tourism to the Space Coast, which we call this area. Predominantly comes to the beaches and to the Indian River Lagoon as a natural attraction. And it's been a capital of sport fishing for 50 years, due in part because it's the most biologically diverse estuary in North America. 2,100 plant species, 2,200 animal species present or were. And then, of course, there's a bunch of us. Maybe not so good when it comes to protecting that system. As wetland folks, you probably look at this picture. This is an aerial picture of a portion of the lagoon, and you immediately notice, hey, I see mangroves and I see seagrass beds, and so you can imagine this to be a pretty productive system. And I want you to take special note with this photo of the water clarity here, and that's going to be a big issue with what we're going to talk about. There are a lot of unique organisms. I would call it characteristic megafauna that people identify with and provide for lots of nature viewing opportunities. Our roseate spoonbill, of course, is one of the favorite birds in Florida, as it is rare. But manatee, sea turtles, and of course our fishermen, like myself, love the snook and other species that are present. And they all rely, to an extent, on seagrasses, right? And there's my seagrass. There's a little bit of a delay here, so. But this complex vegetation community is made up of 3 main species. There's 5 or in some cases 7, depending on where you come from, different seagrass species present here. But the 3 most dominant are Haliduli, Serengodium, and Thalasseum. These are grasses that we're probably all familiar with if you deal with coastal systems in the tropics and subtropics. Now, those systems are in peril at this stage, and the reason is that, well, like most places, we have a problem with fertilizer, and it's well documented. Florida, of course, gets 56 to 60 inches of rain a year, and the Space Coast is no different. Although it's relatively flat, we are a myriad of drainage canals and systems designed to move water off the landscape. We do incur lots of tropical weather, and that makes for a lot of export from our landscape. And I will also say that septic systems are in high use in Florida. Many of you soils folks out there know that these were designed for very dispersed use across the landscape, not high density. Unfortunately, Florida, as it developed in the 40s and 50s, utilized septic systems, and a lot of these systems are still in place, and they're permitted regularly. Now, I will give credit to Brevard County, one of the central counties in the Indian River Lagoon watershed, who has done away with permitting for septic systems and forcing development to utilize sewer. And a lot of the funds that are used to restore the Indian River Lagoon are going toward processes like conversion of neighborhoods from septic to sewer, which is a great thing. There's quite a bit of input here, nutrient-wise, to our system. And then finally, of course, as I mentioned, lots of rainfall. All of our runoff ends up in the lagoon, and that's a big problem. In years past, we have seen algal blooms, but nothing to the extent that is currently the problem now. As an example, and this is from the St. Johns River Water Management District Super Blooms report cover, actually. These are some satellite images of the IRL system depicting relative intensity of chlorophyll. And as you notice, probably the most disturbing part about this is not only is it extensive and tremendous algal bloom, but it lasted quite a while. And I would say that, you know, in terms of the biology of the area, there are opportunities to overcome small blooms and small stresses, but long-term stresses are an issue. And I had a little funny graphic. There it is. I'm speaking with a delay. It's like talking to the Philippines. I am trying to accommodate that. The main thing here is this is a little humor, but it's dramatically not funny when you experience what's going on in the Indian River Lagoon. And I want to highlight the fact that these algal blooms are not only tremendous in their spatial coverage and intensity, but their duration can be dramatic. There we go. And so when you look at a picture like this, you can imagine that the shading events and the impact, things such as dissolved oxygen crashes, etc., can be significant, and over long term can have devastating effects on our aquatic ecosystems. Here is an aerial view of a 2012 bloom as we shifted from a green algal bloom into more of a brown tide. So we go green tide, brown tide, and all kinds of things in between. There's been quite a few different things here, but you can see still the turbidity factor in these kinds of events is not only significant but sustained, and the result there is unfortunate for the biology of the system. As wetland folks, you know, we know quite a bit about that in terms of our systems that we work in, usually anaerobic or sometimes hypoxic. There we go. And the result of those kinds of things are, unfortunately, fish kills, and not only fish kills depending on the organism. If we're looking at Ariumbra or Carinea, that can actually produce toxins, and we end up with not only fish but other animals suffering the consequences of that kind of bloom. And to drive home the economic point, if you're going on vacation and you're choosing a place to go, this would not make it high on your list to find out that there are fish kills and the place smells terrible and you can't get in the water, and you know, marine mammals are washing up on the shoreline. Very similar to what's going on the southwest coast of Florida over the last couple of years with their extensive red tide events. The economic impact of those events is just now coming to light in the tens of billions of dollars lost to potential tourism. So the economic resiliency in my title means that we're very concerned with fixing this system, not only for the beauty of it and the recreational value and the enjoyment value of it, but also the economic value of what it brings to our community. And so restoring water quality in this system can have far-reaching effects in 7 counties, impacting literally millions of people and their businesses. So just to kind of drive the point home, I already showed you some images of impact, but I wanted to make the point that there's not only our brown tide organisms, we have our red tide organisms, Carinea brevis here, and then on the right you see Pyridinium. For those of you that have ever been on a bioluminescence kayak tour in the Philippines or other places, I'm not sorry, the Philippines, Puerto Rico, that was one that we went to from SWS meeting, you will see that this organism is present here too. And while that might be good for some night kayak adventures, it's really devastating for the environment. And I would imagine that we're all familiar with the players that cause these types of things to happen. A big one, of course, is nitrogen in coastal system. That's probably our biggest smoking gun. And you can see in the timetable at the bottom here on the left figure that in Mosquito Lagoon, the northern IRL, and the Banana River Lagoon, that nitrogen spiked and had spiked in the past, but got to a threshold that allowed for these blooms to occur. And then phosphorus, of course, is a player as well, and you can see that result in the chlorophyll. This is in a paper by Ed Flips back in 2015, but looking at those algal distributions and nutrient distributions over the time frame from about 2005 up to 2012, 2013. The figure on the right will just give you kind of an idea of the changes that occurred. And you'll notice that that turbidity not only impacted seagrasses, but all the other things too, especially drift algae. And this is an important part of the ecosystem, which can be sometimes smothering when there's a lot of it. But the impact there is dramatic, and it's from a lack of light. And so that's the big issue when it comes to the vegetation and the primary production of things in the IRL, right? So that seagrass community gets hit hard. My next slide's coming up. There it is. This is kind of a dramatic representation. This is a photo from St. Johns River Water Management District, and I appreciate the use of it, but it does show you very clearly the kind of impact that shading will have in short order. And these are the kinds of things that the public sees. You know, they may not know the dynamics of seagrasses, but they're like, hey, you know, we've got these cool manatees trimming the hedges out on the edge of our property. Well, in actuality, this is a really sad thing to see, because it means they're starving. And that has been the case in the IRL for quite a while. And so much so that the herbivore population, if we try to transplant seagrass, these guys are the first ones on it, and they are pretty efficient, I'll say, at eating seagrasses. And in a normal situation, that's not an impact. But right now, with so little, we see a lot of migration of these guys, and they're very characteristic of Florida and our ecosystem, and we don't want to lose them. In fact, they generate quite the tourism value in their own right. Now, we got to wonder when you have such a dramatic change of primary producers from like vegetation or rooted macrophytes to algae. You wonder, well, where are all the filter feeders? And, you know, and what are they doing? How are they responding to this? And so that's where we enter with the clams, right? And we know that clams were an important part of this ecosystem in the past. And so it's very important to know that they're a potential player in the solution, right? My slide's coming up. I pushed it a little while ago, so sorry, guys. Okay, but so what you're seeing here is Leslie Sturmer holding a handful of hard clams, and this particular species is actually likely a hybrid of two main species: the northern quahog clam, which if you got clam chowder up in New England, you know that's the Mercenaria, and then in the south we have Mercenaria capuchiensis. Now, those species hybridize and are viable without problem, right? And I mean viable, they're reproductively viable. And the cool thing about them is they spawn synchronously. So population density is a very important factor when you're thinking about the success of a species like this. A single clam may produce 1 to 2 million eggs, right? A mature adult, 5 or 6 years old. A 1-year-old clam maybe half as much, right? But they spawn synchronously because these little organisms in a really big world, right? They need to be able to link up in the water column. And so for eggs and sperm to do that, it has to happen at the same time. And their cue is temperature. So as temperatures fluctuate in the spring, from cold to warm to cold to warm, or vice versa in the fall or winter, we have two spawning events, and they're usually kind of close together. So the spring and fall are the spawning times. And the cool thing that they do is, beyond that reproductive strategy, is they provide a service to us called benthic coupling. And that's one that I want to take a second to describe to you, because the physiology of these guys is interesting, but their value in ecosystem services are even more, I think. Okay, so in this, what we see here is this process of nitrogen, and it's being removed by clams in the form of phytoplankton, right? Biomass and detritus. But this benthic coupling that you see in the drawing here, and this is from the shellfish group at UF, that benthic coupling is an important issue, and we're going to see a video of that on my next slide. But the idea is that they're pulling algae and detrital material out of the water column, they're ingesting some of that and using it to build biomass. And in fact, a 1-year-old Mercenaria clam can assimilate some significant nutrients. When we talk about one clam, about an inch wide, about 90 milligrams of nitrogen and about 30 milligrams of phosphorus. Actually, clams and shellfish in general are very high in phosphorus. So if you have phosphorus sensitivity issues, you probably watch out for shellfish. But they do tend to hyperaccumulate phosphorus, which is really interesting and useful for us. But the activity that they perform by filtering this stuff out and actually depositing at the surface allows other organisms to take advantage of that. And we're going to see that. All right. So I have a video here, and I'm going to make sure that I turn the narration off. This is by Jose Nunez and his wife, Margie Lassie. And what I want you to see, here's some clams. They're digging in. This is a thing that Jose created here at the lab. And you'll notice them bury. They do that. We add some algae. And you'll notice the filtration process taking over, right? Their siphons will come up. They recognize there's food. They're happy. They're like, wow, it's lunchtime. Here we go. But you'll also notice these particles floating around. And as these clams filter out, they will ingest a portion and they'll egest some. And you see that egestion materials on the bottom as little clumps of algae. And now they're out of the water column. The water column's clear. Those algae are now clumped together on the bottom. We call that the benthic coupling. And then other organisms, in this case shrimp, come in and take advantage of that too. All right. That's what I wanted to show you about that, because that process is one that we want to optimize in the environment. Pulling algae out of the water column, getting it coupled to the benthos, to the sediment surface, and then making that available for others. We're not going to watch it again, but I'm waiting for the slide. There we go, slide to turn. And so that is an important process that we want to leverage. Now, some other important processes that I think we can all get behind. As wetland people, we're used to our soils, our wetland soils, being great stores of organic carbon. And so carbon sequestration is high on our list of benefits. Well, and I want to promote the fact that these guys do the same thing. And in fact, to a degree that's maybe even more recalcitrant than our organic soil deposits. Your average 1-year-old 1-inch clam at the shell stores approximately 2.76 grams. That's an average number. I should put some error bars on that. I'm sorry. Of carbon as calcium carbonate in its shell. And when I say it's very stable, I mean it's geologic now. I mean, you can dissolve these things, but if you've ever been out and seen limestone, you're looking at sea creature shell material that's been deposited and is very stable over geologic time. So I use this as a piece of leverage when I'm talking about the benefits of shellfish, oysters, and clams. But it's true that the production of these organisms is pulling CO2 out of our atmosphere, which is a very important ecosystem service. Not always highlighted when we're worried about nutrient retention. All right, we've done some other project work here to put numbers on clam filtration. There's a lot of things out there, different studies, and they've been conducted in various different ways. We've done some work here at Whitney with Sean Coggin from Emory, an REU student last summer, or 2 summers ago, sorry. And he's still working on publishing this paper, but it's very telling in the rates of water filtration. We did this in the lab in an undisturbed mechanism to look at clearance rates. And what we found is that a 1-year-old clam does clear about 10 gallons, or filters about 10 gallons of water per day. Doesn't mean that the water's completely clear, but that's a general trend based on the regressions you see here. And that's about double what's been touted as a clam's filtration capacity. Hence, a lot of work's been done with oysters because they filter so much more water. However, there are problems with that in the IRL, and we'll talk about that in a little bit. All right. Whoop, can we go back one? Let's see. Maybe I hit the button too many times. Okay, so the big question is, if these guys are so good at filtering out algae, why have they not fixed this problem in the IRL already? I said they were a significant presence here in the system in the past. And I'm hoping this picture will tell you a little bit, or give you a hint as to why that is. There's 30 or 40 bushels of clams in a very big boat. We'll do the next one. Okay, so the hard clam harvest in the IRL has been tremendous. And if you look at this figure, pounds of harvested clams is not pounds in terms of shells and all that. This is just meat weight. This is meat weight reported. And if you know anything about this industry, you probably will assume, like I do, that we're looking at about 1/3 of the actual landings, right? Creel surveys and reporting often go way less than that. If those of you familiar with fisheries are probably aware of this, I'm going to suggest that this is about 1/3 of what has actually happened out there. But you notice there have been some really strong harvest pressure in the IRL, and that's just Brevard, Indian River, and Volusia counties. Right? It's not counting the southern portion. You'll also note that as that decline hit, that wasn't because the market value was low. That's really because they were becoming harder and harder to find. And I know I've discussed with several folks the legitimacy of saying that this is the cause of our algal problem. Can't do that, but I can say that it's a pretty strong relationship here between the decline in the filter feeder population, and this green arrow here is the beginnings of our nutrient enrichment / algal bloom problems. And this is nothing new. I'm going to say that this has been reported elsewhere, so it's not too hard to see this in other places. And what I'm showing you here is a study by Crowder et al. In 2009, and basically they found a very similar thing. Reduction, of the fisheries landings reduce, and at some threshold, we see a decline in environmental condition. That's where this blue arrow is here. Right around 1999, the algal blooms in Great South Bay in New York started going crazy. And so this is a common issue. Okay, now you might say, well, what effect would that have on these organisms? I mean, it's very unhealthy. We saw the loss of marine life associated with these algal blooms, et cetera. And what we see here is 2012 chlorophyll distributions. This is after the previous satellite images I showed you, right? And we noticed that during this time frame, if you look at the figure on the right, this is from Gabler et al. In 2013. You'll notice that the decrease in shell length in oysters, so their growth has been impacted. I don't have like actual mortality numbers for this, but we do know that from the commercial clam folks, and there's a lot of commercial clam leases in the Indian River Lagoon where clam farmers plant seed clams and harvest them and sell them, at the food market or to restaurants, et cetera, distributors. That in 2012, it was reported a 91% loss of commercial clams in local waters, right? And so the way we know that is that there were claims made to aquaculture insurance. Now, you'll notice that I put, but not 100%. And that's kind of the key to where we're headed here. I'm a biogeochemist. I work in a lab. Let's see this next slide here. With a bunch of molecular biologists, right? So they call me the guy that goes outside. But I work in the environment, and these guys are studying genetics to such a degree and different activities of different genes in marine organisms. And I'm listening to their seminars every week, and it's starting to sink in. Like, oh wow, they're onto something here with this molecular approach. And so I've heard this idea of natural selection forever and forever. And it occurred to me and Jose one day in a discussion that, hey, all the clams aren't dead. Perhaps there's a few out there that have specific traits that allow them to survive. And perhaps we could leverage that to bring clams back to the IRL, and then that would be the key to seeing these filter feeders reestablish in our system. Now, there were some naysayers that you're not going to find any clams down there. They're all dead. And truth be told, that's almost what we found. We were able to locate a few. And we're calling them super clams because after 2 months of looking, and I'm talking about 1,000 man hours, people spread out all over the place looking for live clams, we were able to put together 39 individuals. And remember when I talked about synchronous spawning and how close they are together and how important that is? Well, these guys weren't close at all. And so we didn't find any little clams. They weren't reproducing successfully because they were meters, or in some cases, you know, half a kilometer apart when we found them. And therefore, there's, you know, very little chance that they were being successful. But these clams have been exposed, and I will just say I'm not telling where they came from exactly because we're trying to protect a population that we did locate, but they have weathered the environmental insults of the last decade, more or less, and so we're confident they have the right kinds of genes to allow them to survive, and we're leveraging that natural selection. I would say human-induced selection, right? We caused the algal bloom problem, but that problem then whittled down that population to a very small subset, and we use these guys to spawn the next generation of clams for the Indian River Lagoon. We call them the super clams, and that's really the process we go through. Is we take them back to the lab. When we found these guys, it was in the spring, and they were ready. Jose looked at them and said, "They are ripe. They're going to spawn tomorrow." We went back to the lab, and sure enough, he spawned them the next day. And I call him the clam whisperer for this, but he has a special technique. You know, we get the lights down low, the music just right, and change the temperature of the water back and forth. We call that thermocycling, and off they go. And we end up with little baby clams. We call them veligers until they're done swimming around, and they actually land on the bottom and start burrowing into the sand. It's about a 2 to 3 week process. But you can see them here, and then we take them forward through our own research nursery facility. And you can see on the left, there's one of our broodstock clams Jose's holding over his downwellers. And so we have these systems where algae's added, the water's moving through these tanks, and the clams exist on a screen and are able to filter, and the waste products are removed. And we feed them, literally we feed them cultured algae in the lab to get them healthy and strong. Next stage, they move to the Nursery raceways, where we actually use local Matanzas River water that we pump in and provide them with river water with algae in it to grow. That tray right there is probably 500,000 seed clams, right? And so it's tremendous to see this process go. And we started out with 39 individuals. We spawned about 40 million veligers. And as the process goes along, of course, we lose some. And we ended up with roughly 4 million clams at the end of this process that we returned to the river, or to the Indian River Lagoon, sorry. All right, our field nursery looks a little bit like this. Here they are on the top left, going from seed size, is about 2 or 3 millimeters. We put them in literally in big mesh bags. We attach them to the bottom in the river and grow them up. And after several weeks in the nursery and then months in the field, you can see the bottom left picture, we start to see real clams emerging here. This is what a lease looks like. You can see our Matanzas River Clam Farm partner lease right down the river from our facility here at Whitney. And then our major partner for growing clams, Premium Seafood, that's Mike Sullivan in the middle of the picture on the bottom right, Mr. Jose Nunez, and some staff from FWC, inspecting some of the harvest that, you know, we pull them out of the river right about a year old, and then we transplant them. And then you can see what's going on there. The field nursery part, though, requires a lot of labor. There's a lot of actively checking on these, turning bags, removing. They will bury themselves with silt and such. And so there is some field labor involved in culturing them up. Let's see here. And then we outplant them. And now we've modeled this activity specifically after commercial aquaculture. These partners that we have are showing us the ropes, and I would say my right-hand man, Jose, has been working in aquaculture for a long time, so he knows the process. But we prep a lease area, and I say leases because these are established by the Florida Department of Ag and Consumer Services many years ago for aquaculture purposes in our coastal waters. There are oyster leases and clam leases, and those lease areas are permanent, and there will not be any more. So they're kind of coveted. You have commercial growers that utilize them, but they're protected. So trespassing and or harvesting illegally on a lease carries stiff penalties, as well as the threat of local fishermen getting angry. So they're well-known sites, but they are protected legally, and they give an option for us to outplant our clams. And because we use these aquaculture techniques, we utilize these leases as well, because the process is working so well. In the pictures you see here on the bottom left, these guys are cleaning caulerpa, which is a macroalgae, off of a lease area to plant. On the right, you can see a stretching net at a site in southern Mosquito. And we use that cover netting specifically after we plant these guys to protect them for about a year till they get big enough. You know, they're already almost an inch across, and by 2 years old, they're about 2 inches across. And we were going to cover them with nets to keep them from being eaten by stingrays, redfish, black drum, crabs, and crown conch are all predators. And so these are the guys that we're trying to protect them from. And in the IRL right now, as we outplant, those remaining animals are very hungry, and they know exactly where things are coming from. And so it's a big deal to protect them. Now, we also know from our previous work in aquaculture, let's see, there we go, that these techniques work. We've done some studies in the past. My group worked on sediment size preference by several different aquaculture species. We've tested tools. You can see on the bottom right here a hydro dredge that we can use to harvest these guys. And we've studied, you know, how these activities affect the local waters with turbidity, intensity, and duration, and found that they don't have significant impact, you know, environmentally to those activities. And so we've adopted them and utilized them for the benefit of our project. The last step in that process is repatriating these guys. And so far, we put 3 million out in the Indian River Lagoon at specific locations where we have partners that are letting us utilize their leases. Michael Sullivan up in Mosquito. FDACS has come to the table for our project and actually provided us with an entire lease complex in Titusville, where we're able to, because these are administratively closed waters now, meaning aquaculture cannot utilize them because water quality is so bad. You know, we can't sell those clams for human consumption. So they have let the University of Florida and our collaborators utilize this lease complex to put our clams out. And one thing that I think is really important to note is that that mechanism allows us to space these out without needing additional permitting, et cetera, and get them in strategic locations. As you can see, there's a geographic or spatial distribution of these to help move that along. Now, on the right, you see Norman Kolch, who is a colleague of mine who is ready to plant clams. This is our River Rocks location that you see starred down around in Brevard County. And our process for doing that is actually the fun part, I think, the funnest part. We get groups out, sometimes 3 or 4 of us, sometimes 50 of us, and we bottom plant these. And it's like, you know, Johnny Appleseed. We broadcast these clams, and you can see here in the picture, that's Sabrina in the top left, and Dr. Rex Ellis from the Water Management District in the top right. You'll see Jose in the bottom picture, and Margie, Dr. Margie Lassie in the bottom left. She's COVID conscious. She's got a mask on. This was just this spring. I think she was an early mask adopter, so kudos. But so top right corner, you're going to see what those clams look like. You can just barely see the monofilament cover netting covering them, and they bury pretty quickly. So in about 10 minutes, they're gone. But from the air, you can see, and this is Jose's kite cam You see that string, the bottom right picture. That's us standing down there on the lease area, and you can see these quadrats that are laid out. That's a 14-foot by 50-foot section of mono netting, and underneath are anywhere from 10 to 30,000 adult clams, right? And so we plant them in various densities for some research reasons, but we have many plots here. And you can see as the net gets biofouled, they start to become apparent down there. But now those nets, just so you know, are removed at the end of the process. So after 1 year, we remove those nets and we're done. Next, please. Okay, so current project status. I promised I would tell you a little bit about results, and here we go. So as of now, we've put about 1.2 million clams out in the southern Mosquito Lagoon on a lease complex. I'm going to show you a picture of it in just a second. And about 80,000 in the northern IRL from Melbourne. And we're in the process of moving 1 million clams to the Grant Sebastian area, to Blair Wiggins' family lease there. And we've got 500,000 in transit to northern IRL. Both of those bottom two are about half done right now, and COVID didn't help us with that, so that's a bit of a problem. The results to date, though, for southern Mosquito Lagoon, we have about 19 plots established over 2 lease areas, and we're having great survival. The water clarity down there has been good. The water quality has been good. We've had a lot of food in the water this spring when we got started. And so about 96% so far in our measurements are surviving, and that's fantastic. That's better than expected, right? And our predation issues have been mostly from blue crabs and from some net fouling. You can see this aerial photo. All those blocks there are not just our clams. Our clams are in there, but they're also commercial lease operator is utilizing that space too. And you can see those quadrats are net sections, right? And they foul quickly. We get a lot of gracilaria growing on them and other algae and stuff, and so we have to maintain them, and it's quite labor intensive sometimes. But our northern IRL sites around Melbourne, we've got 17 plots established over that single lease area at River Rocks. And the great thing about that site is it's a restaurant. There's a restaurant that owns a lease. In fact, Mr. Kolsch started that restaurant and was the primary leaseholder. When he sold it, he was able to connect me with the new owners of the restaurant, and they're happy to support the project. And in fact, we have some cool signage out on their parking lot and their dock, and the lease is right out front so people can actually see where these clams are. It's a very, very good opportunity for public engagement. Our survival rate's a little bit lower there, and it's been because of a lot of tropical weather this summer. We've had a lot of rainfall in that area, and so salinities have been problematic. These clams would like to be 20 and above, and we've had some dips down to the 14s and 15s, which has caused a little bit more mortality than we were anticipating. But our survival rate is still high. That's good for commercial production, 85% so far. And most of the predations come from crown conch, which, if you're familiar with them, can come in mass. And we've had a couple of fun little events where we cooked crown conch and made conch fritters. Okay, other results. Just some quick calculations for this year. You know, the clams we put out in this fiscal year are filtering about 30 million gallons of water a day. All right, they're retaining about 270 kilograms of nitrogen, 90 kilograms of phosphorus, and about 8 metric tons of carbon. But those numbers increase exponentially per year. So we expect even a 1-to-1 reproductive ratio, which we know is a gross underestimate, these numbers would increase exponentially annually, right? Once we get these guys started. We've also had some really positive results at our River Rock site. We've noticed 4 clumps of seagrass growing, which means that it's clear enough to get established in the lease area. We're really happy about that, and we're looking at that as being a positive indicator of local turbidity. We're also measuring local turbidity, and I'm sorry I don't have some data to show you, but it's coming. We got an award. This picture here on the right is Blair Wiggins and his family accepting, on behalf of the project, the Marine Resource Council Best Restoration Project at their award banquet this past year. And I think our public awareness is really high. Between Blair Wiggins' TV show, lots of spots on the radio and a couple of newspaper articles, we've really gotten out to the public of what we're doing, and that's resulted in a lot of not only public support but governmental support too. Let's see, and these are just some opportunities to see that. We have 129 registered public volunteers, people that say, hey, when you go out to plant, call me, I want to help. Got lots of positive likes on social media, on our post. And then this is the tremendous part to me, the public in a year and a half has donated over $44,000, literally cash donations to the program. And we've been advertising 10 cents puts a clam in the water, an adult clam, with those benefits. And so people have been utilizing that. All right, some preliminary conclusions. I'm going to say that, you know, the spawning and rearing of this rare broodstock was successful, and we can do it again, and it can be reliable. The same approach can be reliable for restoration activities everywhere. I know this is catching on in Tampa Bay, but it could be utilized in a lot of different places. I think all of our sites right now have a 85% or better survival rate, which is better than what most commercial fishermen expect. And so I think that's indicating that our site choice and our planting methods are appropriate. The full implementation of this project by December of this year results in significant filtration capacity. You know, 30 million gallons a day. When you put that over the course of a year is substantial, along with the retention of nutrients, right? And that's not measuring those nutrient retention numbers. Don't measure the benthic coupling process though, which I think is probably even more significant in the long run. Reproduction in the spring is anticipated for all of our sites. They're healthy, they're growing, they are filter feeding, and so, you know, natural recruitment is going to be a big deal, and that will increase the initial investment and performance of this project over time. And so, you know, the take home is that higher organisms like shellfish that we're talking about today really can be leveraged to improve wetland restoration activities. And the key element there is not just to go grab some oysters or clams, but really to grab the ones that are genetically fit enough to be exposed to this kind of environment. And that means sussing out the survivors of the environmental holocaust in your particular site, and leveraging that natural selection for your purpose. All right. Our future plans include, of course, engaging commercial aquaculture. That's a big deal. Getting those guys involved, growing as many of these clams for export as possible, because removing those clams just means more nutrient removal, but they also spawn when they're being cultured. So that's a positive for getting more clams back in the system. Of course, we're going to monitor our process, and we want to do this for a couple of years. Really make an impact, because we have a long way to go. 3 million clams is a lot of clams, but it's not that many compared to what's been taken out of the system. And we really want to continue our public awareness campaign, outreach events. And again, a big thanks to Addictive Fishing Television and Blair Wiggins himself, who really initiated the public support that's been overwhelming for this project. And with that, I'll say thank you. If you're interested in this, and there's lots of video and lots of other things available on this website, www.irlclamproject.com. That's actually supported, posted and supported by Addictive Fishing TV. If you want to check it out, there's a lot of information there and a lot of activities and other things. And I will take this time now to answer some questions if I haven't run over my allotment. I think you're muted.
Unmute.
There we go.
Thank you, Todd, for the presentation. So let's get started on the questions and answers. Again, I will be reading your questions that I've received through the question and Q&A button to the presenter. The most popular questions that have been upvoted to the top will be read first. If you forgot to ask a question or have to leave before the Q&A is over, you can email the presenter at the email address listed on this slide. So let's go ahead and get started with the questions. I did have 2 questions already posed by one of our panelists. The first one being, what areas, Todd, would you say are the most optimal for outplanting the clams in terms of environmental conditions? How did you pick the best locations for repatriation?
Well, so, our initial, because I can give you a hint of where we found our clams. We found our clams close to a commercial site. And so FDAC said, well, we're going to consider those aquaculture clams, so they need to go back to aquaculture leases. Now, we have since found a wild population as well that is clearly doesn't have any genetic ties to aquaculture. So our wild caughts will be going out anywhere we want, but we were kind of limited to where we could put these. And so we built associations through leaseholders, talking with individual lease owners and asking them, hey, can we plant some on your lease? And amazing, we had an overwhelming response that said, yes, absolutely. We can't produce right now because these waters are so bad. Please come out and plant something there. If it's going to help the lagoon, we're all in. And so we had several owners like that. And then we chose the largest spatial distribution we could to plant. And the reason we did that was we felt like the epicenter of some of this activity are these harmful algal blooms, being Banana River and that nexus of Mosquito and Northern IRL. We wanted to get in there, but we didn't want to get fully in there. We wanted to get our populations growing and start attacking this from the edges. And so we tried to disperse our plantings as much as we could spatially, and such that those reproductive events that are going to occur over time would slowly repopulate in both directions, north and south, from those areas. So we felt like a good spatial distribution up front would then allow for population recovery to occur faster. And that's why we chose those sites. There were a few sites that we didn't utilize because they had too much soft sediment or fine sediments, or in this case, muck is a term you'll hear a lot in the IRL. It's not muck from a soils perspective, but it's an organic flocculent material that is quite anaerobic and very stressful on the organism. So we've avoided areas that were very mucky.
Okay. We have a question from the audience, which is why use clams versus using oysters?
So there's two schools of thought here, and the oyster program in the IRL has been very successful. And I'll say that right up front, that it's not a competitive issue between the two different initiatives, but one that we're trying to add filtration capacity to. And I'll explain that because there's big groups that have been utilizing oysters in the IRL, and they've been doing it with various levels of success, right? The Brevard Zoo in particular has 800 community volunteers that actually grow oysters in cages and provide those for restoration sites. It's a great opportunity. Linda Walters from the University of Central Florida has been kind of spearheading that from the academic side of things, and really done a great job with promoting oyster restoration. Part of the problem, though, that we have is that oysters are not conducive to spawning elsewhere and then delivering, just based on size and weight. So if we wanted to deliver, adult oysters to the IRL, it would be a bit of an undertaking. I mean, more so than 25 refrigerated trucks worth of clams, right? I mean, you can imagine trying to move 3 million oysters would be a big deal. And the goal here was to bring in another species that we know has been removed, but also because we can easily culture them here on site. We can grow them get them through their early life stages, where they're very susceptible to environmental degradation, and then get them out there. When we deliver those clams, they're filtering water immediately, right? We put them in the water and there they go. And with oyster restoration, we're kind of dependent more on the local population spawning, and the technique is to put out oyster culch in bags and bricks and things like that literally these baby oysters will attach to. And so we want to try to skip over that reliance on local reproductive events, and they do occur in the IRL, but it's spotty, and so we wanted to try to leverage the control we can have in the laboratory to spawn clams and then deliver adults back to the system. But I think both programs and both approaches are very valid, and both have a niche to fill in restoring the IRL.
Okay, I think we have time for one more question. Let's see. How would the nutrient removal compare to other methods of removing nutrients? Example, gizzard shad, which I'm going to have to ask now, what is gizzard shad for my own educational purposes? Gizzard shad removal in lakes or algae treatment by consulting companies to help treat algal blooms. So how does the clam nutrient removal compare to those other methods?
Also, I would say that I mean, I showed you some numbers there, but that's not, I didn't show you any other processes, right? Gizzard shad removal, which is something that's done in a papka, can be very useful in removing phosphorus from a highly eutrophic lake, right? And that program has been very successful. It engages fishermen to capture and remove an organism that accumulates phosphorus and feeds on algae and algae detritus, et cetera. Now, in this system, we don't have a fin fish that fills that niche. And so that kind of approach wouldn't be very useful to us. However, there are other commercial applications to remove nutrients. And so the real hinge here in why we don't use just approaches like muck dredging or algal control through application of, like, say, copper sulfate. And that's one that's used in freshwaters a lot. Marine organisms are hypersensitive to copper, as is algae, right? That's why it works. But we can't apply those things in marine systems. So chemical control of algae is not valid in our estuaries. And mechanical control of nutrients is valid and is working very well in the IRL. It's expensive. But what it doesn't do, and this is where the other techniques kind of fall short, is for us to switch from an algal or a water column primary productivity back to emergent macrophytes, which is always a target goal for restoring lakes, estuaries, rivers that are going through this eutrophication process. When we switch from emergent macrophytes to algae, it's hard to switch back. And for the IRL to get back to where it was, or even close, we've got to deal with turbidity. And that's the other aspect where filter feeders, clams, oysters, other filter feeders as well, are doing us the big favor. They're actually taking particles out of suspension in the water column and allowing light to get back to the sediment surface. And that's how we're going to get seagrasses back. And so our final goal here is nutrient removal for the purposes of halting algal blooms. But at the same time, we're trying to switch that primary productivity back to seagrasses and not algae, because those seagrasses will take up nutrients too. They'll also compete for those water column nutrients, but we've got to give them a leg up. And right now, the only way to do that is to reduce turbidity.
Good. Thank you again, Todd, for taking time out of your busy schedule and during this strange time in history to share your expertise and insights for all those seeking to learn more about how we can restore our estuaries. Before we sign off, I have a couple of announcements on upcoming SWS events. Next slide. Our next SWS free webinar will be held on September 17th, 2020, and will be presented by Bill Dooley of the Association of State Wetland Managers, who will be presenting the ASWM's work on urban wetlands and water management. Our next Spanish SWS webinar will be held on September 23rd, 2020, and will be presented by Dr. Ramirez, speaking about aquatic birds, monitoring, wetland conservation, and citizen science in Chile. As a reminder, all the Spanish webinars are offered free of charge to members and non-members alike. And finally, be sure to subscribe or follow SWS social media channels like Facebook and LinkedIn to keep informed and support the society. We also have a YouTube channel where all of our webinars are posted 3 months after their original broadcast with multilingual subtitles, and newly added are our wetland interviews, some in English and some are in Spanish, posted on our YouTube page. You can quickly link to those on the SWS website under the Resources tab and select Wetland Interviews. If you are Spanish speaking, be certain to subscribe to the Latin American and Caribbean region's Facebook page at the link listed here. Thanks again, Dr. Osborne, for your presentation for our webinar supporters, and thank you to our audience for participating today. Have a wonderful day, everybody. Stay well.